a good day.
See you, Mr. Towns.
See you tomorrow.
Yeah.
In the morning. Where's Sydney today?
Oh.
She told you I was going to give you a hard time about this forever, right?
Good.
Until I find something better to teach you about.
Hello. Good morning. Yeah, I get that.
Are you overdosed on coffee or something?
No.
For some reason, the entire right half of my head just like hurts its own.
Right side of your head?
Yeah.
That could be a problem.
My head still hurts sometimes.
Did you Google search to make sure you're not having a heart attack or something?
It's not a stroke.
Heart attack or a stroke is it that hurts?
I don't know, but
Well, I don't know either.
You
It's
had
not a
any water?
stroke.
but I know if one side of your body is doing something, that's a problem.
Well, the smile isn't lopsided, so
Speech isn't slurred.
you gotta do the fast.
My grandma had a magnet of that in her fridge.
For some reason they taught us that in like my elementary school when we were like second grade.
What's that?
Cause like,
What?
cause 8-year-olds are, just start having strokes.
Yeah,
Just
we're
in
all
case-
having strokes.
What's
It's like a stroke test, so it's like F is what?
Oh, is it? Well, it's the lopsided face thingy.
Yeah,
Google
it's
says you
face.
might have a migraine coming.
No!
I don't know.
That would suck. I really hope not. This can't be.
To be fair, I also just Googled it. Have you had any water?
Google's not a doctor.
I've been having more liquids lately than I had before.
That's
So.
good.
Where is everybody? I saw.
Oh, it's F for face, A for arms,
Arms.
S for slurred speech,
And
and
then
then T is time.
time.
Yeah, because you gotta.
You have to
can't
act
take your
fast.
time. You gotta.
Probably just curious.
This is weirdly the second time in the last like week that I've had testing for stroke.
What was the other time?
When my friend was being dramatic and he was just dehydrated.
Oh.
It's probably just like a weird condition. Just
Do you have allergies? You could get sickness
I don't have allergies. It's hard to tell because I was a fan.
Yeah. I'm only a couple shades lighter than that.
Major.
Thank goodness. I'm sorry, but you're the only person who was meant to. Wasn't, no, because if he did bad, then he needs to test, directions on it. Thank the Lord. Thank you for doing
All right, guys, good morning. We are going to start in a little different order this morning because I think quite a few of you actually finished up the ratio tests last time. So I didn't want you to sit there and have nothing to do for half the class. So let me go ahead and introduce you to 10.9. Also, I feel like maybe this is a little bit early, but for this semester, we're only going to get through 10.10. So this will be the next to last new thing before we move into just reviewing for the semester test. So that'll be quite a bit of semester exam review time, but I think that will pay off for you in the end. Okay, Bill won't be here today. Joe won't be here today. Harper's not back yet.
There's 44 that I missed one day.
Thank you.
And I'm so sorry that I didn't come in today. Something happened this
Oh,
week.
it's fine. You weren't even on my RTI, so. All right, so we're gonna go ahead and start this, talk about it for a bit, and then I will ask you to refresh yourself on the ratio test and actually focus on finishing the ratio test. So, this section, 10.9, is about absolute and conditional convergence. So now, for certain question types at least, it's not just a matter of does it diverge or does it converge, but does it converge absolutely or conditionally? So basically what we're going to do is we're going to think about if we take the absolute value of a sub n and see if that converges, and if that converges, we know that the original series also converges. So if it converges with the absolute value symbols, we're going to say it converges absolutely. So try to focus on that. Absolute values, if it converges with those, it converges absolutely. But if it does not converge absolutely, if we remove the absolute value signs, and then it converges, then we can say it converges conditionally. So if it converges but not with the absolute value signs, we say it converges conditionally. And if they both diverge, then they both diverge. So when we are talking, you always want to test for absolute convergence first. So normally we would call, well, we're still going to call this, all of this is a sub n. So I'm going to test the convergence of the absolute value of a sub n. Testing absolute convergence, absolute value. So whatever is in this problem that would sometimes give me negative values, I want to take it away and work it another way. So what in this would ever make a term negative? Okay, the negative on the 3, right? So the absolute value of a sub n is just the 3 to the n over n factorial. Okay, so I'm removing anything that makes it negative. So those are the same thing. Taking out the negative, now it's never negative. So if I can figure out if this guy converges, then the original question converges absolutely. If this guy diverges, but the original question converges, we will say that it converges conditionally. And if this one diverges, if this diverges and the original diverges, then we have to say it diverges. Okay, so this is where, again, this is where Unit 10 really starts to get to be hard, because there's no hint here to do this test or that test, or it's going to be easier if you do this test. There's no real hints in here. So you got to go through your process. You know, if you can see a comparison to do, or if you want to do limit comparison, great. If you think it's geometric, do that. Personally, one of my favorites is the one we started practicing last time that you're going to put a lot of focus in today, which is the ratio test. So the ratio test is the one that I tend to use quite a bit. So I would take n plus 1, which would look like this, divided by a sub n, or multiplied by the reciprocal, that looks like that. And when you do the ratio test to be convergent, you need to see that this is less than 1. If it equaled 1, it was not a good test to use. If it was greater than 1, it diverged. But after we get some of this stuff to cancel, I can see that the limit of this goes to 0. 0 is certainly less than 1. So what just happened was the absolute value of a sub n converged because of the ratio test, is the way I did it. And if the absolute value of a sub n converges, then it converges absolutely. Converging absolutely is going to be the least amount of work. So that's kind of the one you're hoping for. So again, you just take their a sub n, you take away any part of it that would ever make it negative, and ask yourself that question. If it converges absolutely. If that doesn't converge, we have to test the original one, and we would have to do more work. So we'll see an example of that. Okay, so for question 2, if I want the absolute value of a sub n, I do not want this stuff, because this is what's alternating. This is what's sometimes making it negative. So I'm only interested in the 1 over n to a third. Okay, and the infinite series of the absolute value of a sub n, since that's this, does 1 over n to the 1/3 converge or diverge?
Diverge.
Okay, and somebody tell me how she knew that. P series, where P is you look very different today, Joe. Huh? I said you look very different today, Joe.
Yeah, I don't know.
Mm.
Different day.
I need to remember to mark Derek absent.
Whoa.
Wait, Derek's not here. Okay, what is P?
Whoa. 1/3.
1/3, which is less than 1. So that's why it diverges. Okay, so if the absolute value of a sub n doesn't converge, then it does not converge absolutely. So put an X there. But it might still converge conditionally. So conditionally, we've got to work the whole original question. And again, you have to backtrack to the things the list and tests and stuff that we've been piling on to. This is an alternate or alternating series because of the -1 to the n plus 1. So to test the original problem, I could do the alternating series test. And the alternating series test, you ignore the alternating part. And then 2 things have to happen for the alternating series to be convergent. First, the limit as n goes to infinity has to be 0. Is that true? Okay. And the terms need to get closer and closer to 0. So I'm just going to plug in the first few terms. Plugging in 1 for n, you get 1. Plug in 2 for n, you get 1 over the cube root of 2. Plug in 3 for n, you get 1 over the cube root of 3. Are these getting closer and closer to 0? Okay, so the original series converged by the alternating series test. So we would say that it converges conditionally. It didn't get to converge absolutely because the absolute value of a sub n didn't converge. But the original one still converged because of the alternating series test. Now again, if you didn't put a good effort into alternating series test, part of your work today needs to be trying to patch those holes up, because this stuff is just going to start getting intertwined in as we move forward. So these are the two big ones. If the absolute value of a sub n converges, say it converges absolutely. If the absolute value of a sub n doesn't converge, but the original question converges, then it converges conditionally. And then the only other possibility is one like question 3. So in question 3, the absolute value of a sub n would just be n over n plus 2. Does this converge? Does n over n plus 2 converge? Okay, there's too much hesitation. So let's think about, we just go in the list of things we learned. First section was just about the basics. The second section was geometric. Is this geometric? The next test we learned was the nth term test. The nth term test says if you take the limit as n goes to infinity of this, it's supposed to equal
Not 0 if it diverges.
Yeah, if it equals 0, we learn nothing, and if it doesn't equal 0, it diverges. So the nth term test, that's a 2-second question. The limit of that would be 1, because the leading coefficient over leading coefficient, the degrees are equal. 1 is not 0, so that one diverges. So as soon as the absolute, again, I'm trying to focus on the wording here so that you remember the important parts. If the absolute value of a sub n doesn't converge, you can't say that it absolutely converges. But it still might conditionally converge. So what we have to test is the entire original question. So now you have to say, well, go through your list. It's not geometric, can't do the nth term test yet, but at some point you might realize it's an alternating series. And we have a way to figure out if an alternating series converges. It's the alternating series test. Make sure the limit as n goes to infinity of the non-alternating part goes to 0. So the first part of the alternating series test fails, so this diverges also. So your answer is that this diverges. It never converges. It doesn't converge absolutely, because the absolute value of a sub n didn't converge, but it didn't even converge conditionally because the original question didn't converge. So I guess the main thing you need to get out of these first 3 examples, are you guys okay with the difference between converging absolutely, conditionally, and diverging? Okay. Then the next thing they will have us do is trying to figure out x values that would make something converge absolutely. So this is not something that you can just look at and say x needs to be this or x needs to be that, because there's probably a range of x values that it could be. But it does say converge absolutely. Converge absolutely. So the absolute value of a sub n is all I'm really interested in. So I would take out the -1 to the n, because that sometimes makes it negative, and absolute value, obviously I want positive. Okay, and I have to figure out what values of x would make this converge. Well, this is basically the ratio test, which again is going to be your main focus today. I could say if I took the limit as n goes to infinity of a sub n plus 1, So everywhere there is an n, I'm replacing it with an n plus 1. And I split my stuff apart because I know stuff's going to cancel here in a second. This is x plus 4 to the n times x plus 4 to the first. That's like x plus 4 to the n plus 1. 6 to the n times 6 to the first is like 6 to the n plus 1. Divided by a sub n. And for it to converge, the ratio test, that stuff has to be less than 1. Basically, you're dividing by the previous term, and if it's really decreasing, dividing by the previous term should be less than 1. The previous term should be bigger, and if you divide by something bigger, you get something less than 1. So we do this, we split apart these exponents so that we can see that the 6 to the n's cancel out, the x plus 4s to the n's cancels out, and then here's where I really strongly suggest you guys write this work the same way I'm about to do it. There's a lot of stuff going on in this question. But I am going to pull all the n stuff up front. And then I'm going to purposely leave behind the other stuff a little bit to the right. And the reason I'm doing that is because this limit only applies to n values. It says n goes to infinity. So if I just apply horizontal asymptote rules to this, this just goes to 1. Okay, and then now I'm actually almost done. I need to figure out when does the absolute value of x plus 4 over 6, when is it less than 1? Now be careful, there's two ways this could happen. Either x plus 4 divided by 6 could be less than 1, or it could be greater than negative 1. Because of the absolute value, if I can make this stuff be negative a half, the absolute value of negative a half is still less than 1. So you have to split this into two parts. Solve your inequality just like an equation. Just make sure that you change the directions of the signs if you multiply or divide by the negative number. And then now we have a range. Any x value bigger than negative 10 and less than 2 would make it converge absolutely. Because I took the absolute value of the original question, I worked through one of our tests, specifically the ratio test, and I knew it converged when it was less than 1. And I did all of that, and then I gave myself an inequality with just x's that I could solve to find the answer. So that part will be a little bit easier after you finish the ratio test, because that's basically what you do in all the ratio test questions. Okay, let me do one more example here, and then I'll pause and see if you'll have questions from 4 and or 5. Okay, so again, figure out any x value that makes this converge absolutely. So converge absolutely. I want to make sure that I strip anything out of here that would ever give me negative terms, but there's not anything in this question. And for me to figure out what x values make this converge, I'm once again going to use the ratio test. The ratio test says if I take the limit as n approaches infinity of the absolute value of n plus 1 divided by a sub n, if that's less than 1, it will converge. So this is going to give me an inequality in a second that I can actually solve for x, because otherwise you're trying to solve for x in your head, which is just basically impossible. Now again, I just skipped this step a minute ago, but when you've got an exponent like n plus 1, you really want to start making the habit out of calling it x minus 1 to the n times x minus 1 to the first, because then you can see the x minus 1 to the n's cancel. My advice to you is going to be make one extra step and put all the n stuff up front and put all the other stuff kind of lagging behind, because the limit is only going to apply to the n stuff. So the limit of this n stuff would go to 1 because the exponents are the same degree, so leading coefficient over leading coefficient. So I know this is going to converge when x minus 1 is less than 1. Sorry, when the absolute value of x minus 1 is less than 1. So that's going to occur when x minus 1 is less than 1 and when it's bigger than, what number do I put over here?
-1.
Good. I didn't know if y'all ever learned how to solve inequalities. Add 1 to each side or each piece, and then there is your range of absolutely convergent. Now notice it doesn't include the 0 or include the 2, so those values could still be conditionally convergent, but only the values bigger than 0 and less than 2 are absolutely convergent. That's what they asked us to do. If we wanted to know if x equals 0 was conditionally convergent, you could plug 0 in for x up here and work the question normally. You would have the alternating harmonic series, alternating harmonic series converges. So x equal, this has nothing to do with this question, but you could figure out pretty easily that x equals 0 converges conditionally. Didn't converge absolutely because it didn't include, like this inequality solve didn't include it, but you could test it independently. Same if I plugged in 2 up here. If I really wanted to know what x equals 2 is it convergent, 2 minus 1 is 1. 1 to the n power is always going to be 1, and 1 over n converges or diverges? Diverges. So it's conditionally convergent at x equals 0, if you cared. It is divergent at x equals 2, if you care. But this ratio test, if a sub n plus 1 divided by a sub n, if the absolute value of that is less than 1, then it converges. So just do that, do the limit piece, and then solve the inequality to figure out what values of x make that true. Okay, I would like you to try, let's just pick out maybe 2 or 3 of these, and then I will give you the rest of class to worry about 10.8 if you're not finished with it. So I want to pick out some that I think are good first tries, such as go ahead and start with question 3. I'd like you to do that one. Try question 5 and 4. Try 3, 4, and 5. I think that's going to give you a small sample of the different things you're going to be doing. So let me give you 10, 15 minutes to try those 3. We'll go over them to make sure that you make any corrections you need to, and then I'll remind you what else you need to practice during class today. Okay, I'll give you some more time for the other ones, but I feel like you should at least have finished thinking about number 3. So, the quick answer is that number 3 converges conditionally. So, if you were pretty confident about that and got that as an answer, then I guess you can tune me out. But this starts off as an alternating series. This cosine of pi n is going to make this alternate between positive and negative. So when I'm testing absolute convergence, I would not include that. So this is the absolute value of a sub n. This is the harmonic series. So you should recognize that it diverges in about 2 seconds. So it does not converge absolutely, but it might still converge conditionally. So to figure out if it converges conditionally, you have to try all of this. Realize that this is an alternating series. So you should be applying the alternating series test, and 2 things have to happen before you can say it converges. The limit as n goes to infinity of a sub n has to be 0, which it is, and each term has to get closer and closer to 0. So plug in 1, you get 1, plug in 2, you get a half, plug in 3, you get a third, then a fourth, then a fifth, then a sixth. Those are definitely approaching 0. So it does converge by the alternating series test, but we can't say it absolutely converges because it didn't converge with absolute value signs. We can only say that it conditionally converges, or converges conditionally, or conditionally converges. Now, one last thing I want to say about this. You could have also skipped all of this if you took my advice and memorized this. I told you this is going to be one of the most common things that shows up, and it's probably worth memorizing. The harmonic series diverges, but the alternating harmonic series always converges. So it's not going to hurt you to figure it out by doing the alternating series test. You have to know the alternating series test anyway, but alternating harmonic series always converges. So when you recognize that, you're welcome to make that jump. Okay, I'm going to leave that up for a few minutes and then keep going on 4 and 5, please. Would anybody like longer on question 4? Okay. I'll tell you up front, in the end, this series diverges. It does not converge conditionally or absolutely. So if you were pretty confident that it diverged, then you're probably in good shape. But for the rest of us, you should have tested absolute convergence first. So take out anything that makes the terms negative. So this is what you should have been focused on in the first part of the question. And then you should have asked yourself, does this converge? And again, it just depends on how familiar you are with our previous test. I can look at this and tell you that it is going to diverge very quickly because the limit as n goes to infinity of a sub n, I'll even FOIL this out, is 1, which is not 0, so it diverges. I just used the nth term test. I saw that the limit wasn't going to be 0, so I knew it would diverge by the nth term test. I didn't have to spend very long on that. Okay, but just because it doesn't absolutely converge doesn't mean that it doesn't conditionally converge. So, conditionally, then you have to test the entire original question. You've got to realize that it is an alternating series, so you have to finish it by working an alternating series test. So again, if you're good at alternating series tests, then you're just about done, and if you didn't learn that as well as you should have, then you're still going to be struggling there. But alternating series test, in an alternating series, you ignore the alternating part, call the rest of it a sub n, and then two things have to happen. The limit as n approaches infinity of a sub n has to be 0, except this one's not 0. This one is 1. So the alternating series test fails, which means it diverges. So your answer is that it diverges. This does not converge at all, not absolutely nor conditionally. Okay, let me leave this up and I give you a couple more minutes for question 5. And then we'll go over it for sure before break, and then you can put this aside till next class if you need to work on the other one. Okay, I'm going to cut you off on question 5 already because this one should have been much easier. Like most of these, they vary in difficulty quite a bit. So if you tested absolute convergence first, which is the most restrictive test, you got this, does this converge? Basket. Does the absolute value of a sub n converge?
Yes.
It converges because it's a p-series. Again, make sure that you can be able to write all this for an FRQ. It's a p-series where p is 5/2, which is important because it's bigger than 1, and that's why it converges. That's my justification. Okay, well, if the absolute value of a sub n converges, then it converges absolutely. That is more restrictive than converging conditionally, so I don't need to test anything else. If it converges absolutely, you get to be done, and then that's why you should start with that one anyway. Okay, so I know you guys are going to be in a couple different spots here. So again, I wanted to start class with this today because I knew a handful of you were already done with the ratio test. So I would love if you could work on this more, but the real priority is on ratio test. So I'd like you to finish that up first. So you need to spend a few minutes looking at our examples we talked about last class, what the process is, knowing that when you do that process, if it's less than 1, it converges, greater than 1, it diverges, and equal to 1, you don't learn anything, and you need to make sure that you can execute that. You can see that we use the ratio test even after 10.8. So. So if at all possible, I would like your 45 turned in today. And then you're welcome to move on to 46 if you still have time. It's not there yet.
Huh? I thought it was pretty good.
You think it's past the drop down?
Maybe not the handle.
You should try it.
I'll drop it on your head.
Oh.
I'll make the other half of your brain hurt. Balance it out.
We tried it. Scientific method for it.
But then we'll need more like test cases.
Well,
Have you
we
seen
gotta.
that among-
Somebody's got to be the first.
You're the control variable.
If I'm controlling it, you don't do anything. You just let me alone.
I looked at it too. Bless you.
Yep.
Yeah, but I'm gonna eat it. I like lunch.
Either one's fine. Thank you.
Well, I don't know. Wait, someone's been tricked. This is video with people.
That's your cousin. You already get it.
Yeah, I know. I'll bring it back.
Okay.
That's just a skinwalker tree.
Alright, this is your 1 minute warning.
I'm so sorry. So for 41, that quiz that we took,
I just thought
Doing that was thinking.
Yeah. Wow, this fish is gorgeous.
The fit is crazy.
Where's Harper at?
I have no
Oh, he's probably skipping.
hell if I know.
Does this sound like
I have something to tease him about.
there's always something that he's Harper about.
Wait, can I?
Oh, you got it.
Maybe I'll just still do it. You should do it, honestly.
No, use this one. You don't even have to unravel it. Bro, I see Nicole on Friday.
Really?
Yes, and Saturday.
Are you going there?
No, we have a model work conference.
Oh.
Yes. The ASMS science. Is this good? Should we make it this line?
Yes.
You know what I saw for anything? It was the school play.
The AGS?
No, the school play here. She surprised me. It was like the worst day, but we saw almost winning that. It was so bad. We had to watch Alvin strip on stage.
Ew.
I know. It was good otherwise. Like some parts, like Andrew's really good otherwise. When we had, like,
I had to swallow out.
Nicole has some
Maybe not.
his breed.
It's already.
Meg, check out.
My breed is consuming as well.
You are the worst. Not really.
Okay, I need to give you, remind you of the directions here and then give you some updated information as well. So, again, I'd like you to put your focus on 45 first. Make sure you have the ratio test finished. And so as you get the things that you need help with on that, I need you to let me know and let me help with that. I don't see how you would not finish that unless you were gone last class, since you worked on it last class too. So please turn it in as you finish. And then you can go back to the absolute versus conditional convergence. And if you finish it also, I will let you turn it in today if you'd like. It's not due until after break. However, if you finish 45 and 46 and you get both those to me, I will give you your recent quiz back and let you start looking that over. So the recent quiz was the one over 10-1 through 10-5. It was 10 2-point questions, and they were all AP questions, so I didn't do a curve beforehand. So I am going to let you do corrections on the number 41, the 10.1 through 10.5 quiz. And you can get half of your points back. So if you miss 10 points, you could get 5 back. But I'm not going to pass that out right now, because if I pass it out right now, you're going to focus on that and not the stuff that you need to do. But if you finish 45 and 46, I would be happy to let you have it. Otherwise, I would be happy to let you have it at the end of class. And then similar to when we did corrections earlier this year, I don't have an exact timeline. Like, it doesn't have to be done in 2 days or 3 days. I think the sooner you do it, the better. But as long as it's not like last minute before the semester ends, then I'm happy to take them, because I'm happy that you're looking back and learning from your mistakes. So. And even though that might sound like a lot to turn both these in to get that back during class, there's already 4 people that are done with 45 and 46. So neither one are terribly long unless you get stuck. And if you're getting stuck, you need to ask for help. And again, if you don't feel like you need the points, you don't have to do the corrections. Some of you did very well on it, so you may not be interested in doing any corrections.
Yeah, but we have to have those corrections done.
As long as they're not last second by the end of the semester, I don't care. I think the sooner you do it, the better, because if you see that you missed the P-series question or the harmonic series question, like, that stuff's still coming up. So I think it's in your interest to do it as soon as possible. But as far as grade and stuff, as long as it's not last second at the end of the semester, I don't care. Yes, ma'am.
Can I get mine?
Thought I'd already passed yours back.
Like, you give me the polar one.
Oh, okay. I might have put it in a different stack because I didn't see it here, and that's partly why I thought. Let's double check though. Okay, it's not in this stack, so let me check my other BC class. You don't have to wait on me, I'll find it and bring it to you.
I guess so, but
That's weird.
Oh, well, y squared So say this is point two, one, point one. Sorry, the top is point. X is point two.
Now, if and when you get to doing corrections, please do them on a separate sheet of paper. If you do them on your quiz, I can't tell the difference between what you originally did and what your correction was. So, if you don't put them on a separate sheet of paper, I will ask you to do that.
For the corrections, do we just need to solve it again, basically, on the separate sheet of paper?
Yes. Just work it out to show why the correct answer is correct.
Okay.
Unless, if there's not much for you to show, then maybe you
Like
could explain why what you picked didn't work or something would be fine. I'll tell you when I see it, so.
Is that only for the last quiz we took?
Yes.
Yeah.
What was the other one?
Well, I was just wondering if those corrections for all quizzes were.
Oh, no, definitely not all quizzes. Based on average.
Okay, 0. Yeah, because this is the sum of the two factors. So if the x is negative 1, then over 1. A over 1. If A over 1.
Yeah.
So my computer is going crazy because I can search up pi.
So it's A1 over 1 minus 1, right?
It's blocking every
So
single thing.
A1 is 0.
And I've already reset my computer
That's 1, right?
twice.
So
Should I
1
take it
over
down to
1
10?
minus This is negative.
Because like anytime I try to do it.
I mean, I have a few things
Well, if you
blocked,
eat
but
it-
this shouldn't be.
Like I was
If the x we can't move it up. Okay.
Is it just Google? It's gotta be just Google search.
So.
Yeah, see, I think it just depends. What are you trying to search?
Well, actually, I was trying to put hack and then it just blocked
So
me. And I guess I
Try it again. Like I said, I do have a few websites blocked, but yeah, it takes a couple seconds. Yeah, I think they should all be fine. I don't know why the Google search would be messed up, but
Ace of N would be this.
if you need something specific,
X negative ace.
maybe it just got confused for a second.
Or
Well, bring it back up here when you see it again.
Alright. I always thought it because like it's blocking high.
No, it's not blocking. I think sometimes it gets confused for a second on what it's blocking, but I didn't block anything like that.
Oh, you mean for this? For this
Wait.
one, for X negative.
Wait, okay. Yeah. Wait.
But that would be equal to
X is negative. Should one ace of N be 1 over 3 plus X. That's not what we want to do. This negative X. Because
No, but if X is greater than 1, R would be greater than 1. And that means you're backwards.
X is greater than
And that means there's like
Excuse me.
Do you need the quiz back also?
Just to see that it was the only thing you missed.
There's absolute value of R. Greater than 1.
I wrote out the correction for you.
Oh.
There you go. Okay, I'll update. Thank you.
Mr. Dunn,
Yes.
why is number 2 C?
Because it's the right answer.
You're right. Okay.
It's just the same.
Okay. Are you concerned about the first part or the second part?
Second part.
Okay, so second part, the reason why x has to be positive, if x was like, let's say -1,
Yep.
then this would be e to the negative k, which is like 1 over e to the positive k.
Yep.
So that changes, that would change the rules of how the geometric's supposed to work out.
Well, it would just be 1
Yeah, that's
over
what-
e
That's
to
what I was
x.
saying.
But
That would just be r.
This is what I get to bring in.
And r would be less than 1.
I wonder if
But
it's
r wouldn't be e to the x anymore. It would be 1 over e to the x.
Yeah.
Then that doesn't match up with the first part of the answer anymore. What I'm saying is, if x is negative, then this is your R is gonna be like 1 over e to the k.
Okay, yeah.
So then when you do that, it would give you a different value there.
But if x was greater than 0, wouldn't r be greater than 1?
That's H now.
Well, since x is still in there, no, that would be fine.
But
If x is greater than 0, r is still gonna be e to the x.
Which is more than 1.
e to the x is more than 1.
Why would e to the x be more than 1?
Because
You don't know
x
anything.
Because x is greater than 0. X is greater, or it could be less than 1.
Until e to the x is, so like
Restack that.
e to the, and x is a decimal.
Positive, positive, and
This is what you would think the sum would be
Two random words. Integral
if you let
test
x be negative,
and
Yeah.
which isn't any of those choices.
Yeah.
Okay, if x
But
is positive,
x to the, if x was 1,
okay, then r would be e to the k. And you would get first term over 1 minus r. Okay, but k is this value.
Yeah.
It's like your n, so this.
but 1 minus, or like e is greater than 1.
That's true.
And e is r, right? Or e to x is r.
Yes, e to the x is r.
Yeah.
Yeah, I'd
That's,
say. Yeah.
is that not bigger than 1?
Is e to the x bigger than 1?
Is it not?
Well, it's only the denominator. I mean, I don't understand the concern, I guess.
I mean, it wouldn't always be greater than 1 if x
Yeah.
is less than.
If
But-
x was a decimal.
But if x is greater than 1,
Okay.
for number 3,
Okay.
if x is greater than 1, then r would be e to the some number greater than 1,
Correct.
which makes it divergent,
Why?
because r is greater than 1. Because e to the some value greater than 1 is greater than 1. E to the x where x is greater than 1 is
Okay,
greater than
hold
1.
on. I understand your argument now. So you're saying e to the x has to be bigger than 1 because you know x is greater than 1.
Or if x is greater than 1.
Okay, but this is 0, not 1. So I'm with you on 1.
But, so it's not convergent for all of x greater than 1. So it'd be x greater than 0 and less than some number.
Yeah. For this to be true, it would have to be x is greater than 1 and less than, greater than 0 and less than 1. Because otherwise it would diverge.
Okay, let me think about it a minute. Let me find a blank copy and I'll try to find a better argument for you.
Okay, thank you.
Could I get my quiz done, please?
Alright, did you turn in your work?
Yes, I did.
Okay. There's no corrections on that one. Not that you could anyway, but. And this is the one you can. Thank you.
And I know that the answer is probably no, but would it be possible for me to leave like 5 minutes early? Because I have to be on the VA, or at the VA at Township at 2:15.
Fine, just for one time.
Okay, thank you so
Yep.
much. I'm
Just
meeting
remind
with,
me
like,
on the way out, though.
people. Okay. Perfect, thank you.
Huh?
For that question,
Yeah.
Can I look at my tab? Or
Oh, are you done with
quiz?
both those?
Yeah.
Sorry.
Very good.
but it's the same question?
That's the one you cannot do corrections on.
Okay.
Oh, it's the same.
Well, actually, you could've marked it wrong.
This one you can.
Okay. Thank you.
Does it say like if x was less than 0, it would be this and not this?
But also there, you make the argument that you can't flip it, because if x is still left as the variable. So it hasn't been flipped yet. If it went to 1 over e to the x, it'd be 1 over e to the negative x. Because the negative x, the x hasn't been plugged in yet. You know what I mean? Like x is negative, but it hasn't been plugged in as negative yet, so it's still e to the x. So you make it 1 over e to the x, you 1 over negative e to the x, and you plug in the negative source and then show it.
Yeah, but that would be. That'd be one.
So we what?
That'd be one.
No, cause it wouldn't go up again, cause it would be down and be negative x. I can write out what I'm saying.
Oh.
You see what I'm saying?
Wait.
If you make it 1 over e to the x, before you plug, if you flip it, it'd be 1 over e to the negative x. You don't plug in x, you don't know it's negative. So then when you plug in x, it'd be negative in transfer and then go 1 over e. If you plug in x,
yeah.
it'd still be e to the x, or 1 over e to the
Would
negative
be
x.
one. Oh.
You can also argue that. That's also a good argument.
Yeah, that makes.
So if you don't flip it, okay. And I'll try to explain it. So that question is just.
It's a very good question.
What?
Said it's a good question.
Really?
It was a previous AP exam question.
Well, I have another reason why I feel like it's done.
Another wrong reason?
What was the form you have?
It was the e to the k.
Yeah, let x be a real number, which is the form.
Yeah, so she thought, she got the same answer she got right. I got it wrong. And so did I.
So like on the other form, that one was marked as correct. Yeah, I got the other one. But it looked incorrect, so.
So why did you mark wrong?
Well, I mean, we're talking about.
It's just probably this form. They got, the answers got marked for each.
Like, why would it be different?
A human error problem. That one last, the last thing.
Yeah.
Oh, like definitely.
Are you having any
That's
fun with these?
Like in person.
Yeah.
Yeah. Like, hey, everyone should try cheese.
I'm gonna do my thing. Let's let me do it. If he comes to us, I'll say that. He probably. I also have another reason. You still disagree? You still disagree?
What's your question? Where's your original question? It's two different forms. No, me and him have the same form.
That's the question.
And you think the answer is what?
I'm just supporting him. Don't change my answer. I did the test. I'm arguing for him as opposed for me because I think that is more accurate.
Wait, so are you gonna argue for you to keep points for C, or you are
I mean, you
gonna?
can't go back and change it, right?
It's supposed to be B.
Yeah.
I have it wrong in mine.
Yeah. Because the other form also
There's all
says
the other
B.
forms that do A, yeah, for them. They're like the same answer.
Yeah.
Oh, okay.
Yeah.
Was that your other argument?
No, I also.
Okay. Yeah, so this was a different form, I made a different form this year and I messed up when I made the answer key, I guess, so. So on yours, you can just say that you had right originally, and I'll make sure I give you both true thumbs. And I'll take out 14 points.
Are you gonna go back and change yours?
For you?
Yeah.
How long? Unless I remember.
Thank you for bringing that to my attention. So you're saying it was graded correctly on the other form?
Yes.
Yeah, it looks good.
E.
Actually. Derek, I'm actually just gonna add 2 points right now, so I don't forget. I did have one mistake on our recent quiz for just one of the forms, so I know a couple of you have your quiz already. So I need to come by and double check real quick that I didn't mess up one of them. This one, that's supposed to be B, so you got lucky here. I think that one's fine. Yeah, I'm not gonna take points away.
And you can always just go.
What
into
if I
the-
miss?
I need to regrade those, I guess.
Wait, so then, can you raise the power of the- Here, okay, I remember. I mean, I remember, I see the rest of it, anyways.
I didn't do anything. Okay, so this one, right? And then
Fix yourself,
what was you good? This one of it.
yeah, and then raise the power,
I think it's just the same.
raise the power of the, here, divide by 2.
And making.
If I did it from here, I would have priced it up.
Each for one of them is. What's it? Whatever X over X.
Times, you really wanna, and,
Or u to the one over X over X. Because you multiply by the inside.
Oh, well, it's just e to the x, this is the root.
Yeah. And so why would you? Why don't you do
Because this is a really messy. I don't know how to integrate that.
that? I don't know how to do u to the one over X.
I don't know how to take the root of that, and I did.
Yeah. And then
Oh, it's not use of, I see.
u over X and then it's.
I see, yeah. Yeah, yeah, okay. That's what I needed.
Yeah, honestly, it's content.
Because if you use sub, then it goes to use square. No, but then it's not one, it has to, you have to do sub, and then the balance it out.
That's in the hard parts of that graph. Well, then you get the question where it's like conceptual, I like know how to do it.
Oh, no, no, no.
Yeah, it is what it is.
Or you can do infinity. Okay.
Wait, this one's due September. Yeah.
I got it.
Oh, and then that would be negative. So that
I just don't get, I mean, you take the use of, I don't know why it doesn't.
it'd be u over X. That means I ain't coming. No. It'd just be u. Go with the X, go.
Six squared and the root.
Thank you, just give me a second.
And over.
Are these both yours, Mark? Okay, somebody turned it in a ratio test thing for you that didn't have a name on it.
Oh, it's like me.
So it's negative.
So it's negative u.
It might be you.
Right, so then take the.
So what you said?
Equal that.
That's not mine.
You square over two.
Probably maybe.
Did you turn it in like in the last 5 minutes?
Yeah.
Okay. I haven't graded it yet, so. You want your quiz? Okay, give me just a second. Do 2. That's 2 quizzes ago. And then the one that you can do corrections on. That's the one you can do corrections on.
Oh, okay, yeah. I got it.
Raise the power button. Okay, yeah. You lower the power.
Okay,
And then multiply by the new
power.
power. Yeah, so it is over.
You will need to turn in your quiz when you do the corrections, so make sure that you don't lose it.
1 over x squared, so
Kill only gets one if you need to.
And then
the ribbon.
There's just so much more.
Understand the concept a little
Which, where is the 2 then? So then you go to u, and then you go to negative u.
and then
Windows return.
Sorry?
So I don't know if the return window's up for this one, but I've got
Oh, no, that's fine. It's recent. That's good.
Anyway, sometimes I remember this when we were sleeping. How inappropriate.
no, under 1.
I don't know if I should learn why
She didn't.
or if I should focus.
The question you didn't do?
I love playing violin. It's because I'm good at theorizing and then it feels that's good. I know, I just wish that like, I think I would have drawn to look at a lot more if the upper school had certain tones was like 1%. Because where I'm and then I'm like,
Here's 2 quizzes ago.
And like, what spelling corrections do you have to take?
Yeah, anytime. Not last second at the end of the semester. I don't care.
Oh, okay, perfect.
So.
Thank you so much.
Has anybody got any fun plans over the break?
visiting my family in Texas
That's fine.
a little bit.
Do you get along with your family?
Like, do you have cousins and stuff you like to be around?
Yeah, I mean, I have cousins, but some of them get on my nerves really quickly.
What are the names of the ones that get on your nerves?
Yeah, it's actually not that deep because they're all like 30, so I can't have beef with them. It's like weird. Really?
Yeah. I think I have 10 younger cousins.
I think I have one younger cousin.
Why are all your cousins so much older?
They were born before me.
I have 9.
I guess that's true.
And I have 1.
My mom is like pretty young in her family, so all of the cousins on my mom's side are a lot older than me.
So your mom's the baby and then you're the baby?
She's not the youngest, but she's like on the younger side. She has a lot of siblings. They're just all competitive, and they're all Asian. They like call me fake.
Because you're Asian.
Yeah, because I'm Asian. They're like, you look so white. Like, oh, you don't know Vietnamese. What a loser. And then like I feel awful about myself. I guess I'm more confident. And they live in Houston. Houston's kind of middle. It's probably true, but the only time I'm there, I'm at like the Houston suburbs, and I only have to say, and it's hot. I don't know where I am. I'm away from my parents. It's around my cousins.
Well, okay.
Why don't we write her down?
So it goes negative integral from e to 1 of u.
Right now.
And you see the root of that, you get u squared over 2. So this would be over 2. And don't do u subs. Works. But like, that'll get rid of that u squared. The u squared over 2 is anyway that you squared
But you're not integrating you. Okay, here's your problem.
Yeah.
Bruh.
If you try,
I like scrambled.
that's the wrong u. You can't make this stuff replace this stuff perfectly. If you make u be 1 over x, then du will work. And this won't be a u, but it'll be an e to the u.
From American Psychic. Are you serious? Yes.
See, like from defining your u and your du and then setting this up, you're skipping too many steps where you don't realize that these pieces don't actually fit those pieces perfectly.
Because it's accounting for e to the 1 over x.
Yes.
Okay.
Make u be 1 over x only.
Not really, no.
Is that what you're saying?
Well, relatively new, but I've had it the whole school year. Because brown's my favorite color.
Is it really?
Yes. I wear a lot of brown.
Huh?
I wear a lot of brown, so you can wear that way.
Have a nice break.
You too. Actually, you'll